Thank you for sharing. So,
Yeah,
it's
thank
all
you very much.
yours, the stage.
Yeah, thank you. Very good morning, everyone. So, first of all, thank you very much for all the audience. I really appreciate your presence here. Yeah, without wasting time, we'll move to the today's session. So, today I'm going to discuss about how we can host our automotive application to the cloud using the resilient architectures. Uh, Before moving to the slides, first of all, I will introduce about myself. My name is Chamila Walisundara, and currently I'm working as a consultant to the wireless car through XP Pro. So yeah, that's pretty much about me. Without wasting time, we'll move to today's agenda. Yes, first, I will give a small introduction about how important is resilient architectures for the automotive applications. Then we can talk about some challenges that automotive industries are facing currently. Then we can talk about some key components of the resilient architectures. Then we are going much deeper and discuss about fault tolerance design strategies. After that, some fun parts like we can discuss about some real world case scenarios. Then you can correlate my theory part with these practical scenarios. Then I'm going to specifically talk about security aspects and the monitoring. Finally, I will explain about how we can continuously improve this process. After that, we have time to discuss about if you have any doubt or question about my session. Okay, yes, introduction. So in here, we'll discuss about why this high availability or the resilience of these automotive applications are very important. So if we talk about, basically, if we talk about automotive applications, these applications should available around the clock because from that aspect, the cloud resilience strategies are playing very crucial role even during a outage like such as hardware failures or network failures or unexpected high demand. Regardless of the outage type, these automotive application should work without any interruption to the customers. Why it is that much of important? As you can see, the first one is safety and the emergency services, because as you are aware, in the modern vehicles are coming with collision detection system, emergency braking system, automated emergency calling system. So altogether we call them as ADAs, Advanced Driver Assistance System. So these are very critical from the safety perspective. In order to work these safety and the emergency services, the related applications that are hosted in the cloud should available around the clock and should work without any interruption to the end customers. Because if there is any outage or any interruption of these features, then it will affect to these safety features. The next one, the next important thing is reliability and trust. So how many people in here using remote services? I mean, if I simplify it, how many of you are using, how many of you are using your mobile phone to control your vehicles? Yes, we have some people. So basically, most people are using their mobile phone to remotely control their vehicles. What are the features? Like you can control your air condition system. You can check the status of the battery or like door unlock status. I mean, a lot of remote services are available. So in order to work these remote services very smoothly, the related application that we are talking about in the cloud should work without any interruption. Then only you will get a very good trust from your end customers. that's really important. Then continuous connectivity. So, in order to work most of these automotive features, it's required real-time data. Like if you talk about weather information, traffic information, these features are mainly depend on the real-time data. So, in order to ensure the real-time data, we need a very strong connectivity between vehicle and the back-end application. That's really important. Then operational efficiencies. So, if we talk about the vehicle manufacturing process, so we call it a production line. Personally, I know how much is crucial the production lines are, because these production line process are very time sensitive. If something happen to these applications that are hosted in the cloud, the whole production line go offline. It will impact to delivering the vehicle from the factories. So that's why it's really important. The next one is autonomous driving. So in this era, most of the people are talking about vehicle driving without a human being. So in order to success this autonomous driving, it's required real-time data, high power data processing unit. So it's not a single thing. It's a cluster of lot of features. So in order to success the autonomous driving, the related application should work without any interruption around the clock. So that's why it's really important. The final one is customer experience and the brand reputation. So now we talk about a lot of features, right? So if these features work very perfectly without any downtime to the customer, your application will get very good reputation, or you get very good customer satisfaction for your application. It will help to increase the brand reputation. Okay, now I think you can understand about why the high availability of these autonomous features are important. That's why we are trying to talk this topic. Okay, now next we'll talk about some challenges that automotive industries are facing these days. So basically, when you are deciding you are going to host your automotive application in the cloud, from that point onward, you are facing some challenges. Why it is very specifically for the automotive industry? As we talked about previously, most of the automotive features are depend on the connectivity, and most of the automotive applications are depend on real-time data. In order to give the real-time data, we need a very strong connection between vehicle and the backend, as well as these data should flow between vehicle and the backend application with less latency. Then only we can give a very smooth application experience to the customers. So the first one is the connectivity dependency. We talked this previously as well. So it's mean in order to give the real-time data, we need very strong connectivity between vehicle and the backend. It's very challengeable. So in the normal urban areas, it's not a very hard thing, because we have very good connectivity like 3G, 4G, 5G connectivity. So it's not much hard to build a strong connectivity between vehicle and the backend in the urban areas. But if we think about some vehicles are going to very poor network areas like inside forest or mountains. So in that aspect, it's very hard to establish very good connectivity between this vehicle and the backend. So in that case, during that time, it's very the applications that are running on these vehicles are not working as expected. So it's very challengeable. The next one is the scalability and the cost management. Yes, all of your cloud providers are giving very high scalability for your application. In the same time, you need to think about when your underlying infrastructure going scale up or scale out, the cost also going high. So in order to manage between scalability and the cost management is not an easy thing. It's challengeable. Next one is the latency issue. As we discussed earlier, the data flow between vehicle and the backend should be run without any latency, with a few latency. Otherwise, we can't get the real-time data, especially for the traffic information, navigation, weather information. These data should come to the vehicle without any delay or with a less latency. In order to maintain this less latency is not an easy thing. It's challengeable. Next is the data security and privacy. Very important topic, because in the automotive industry, we are dealing with personal sensitive data. To ensure these data security is not an easy thing. It's very challengeable. Then the data redundancy and the backup. What the data redundancy mean? Data redundancy mean we need to duplicate these data to a different geographical region, as well as we need to take backup of these data. So not only taking the backup, we need to offsite these backup, we need to archive these backup, and sometime if required we need to retrieve these backup. It's a very hectic process and very challengeable thing. The next one, the disaster recovery. So you depend on your application. You need to decide whether you need a disaster recovery solution or not. Disaster recovery means what are you going to do, and or how we are going to serve if something happened to your primary location, how we are continuously supporting to your customer. It's not an easy thing. It's a very challengeable. Then the integration with legacy systems. So some companies are still not 100% in the cloud. Still some companies are running on on-premise, leverage on-premise data centers as well. So how the integration between these legacy application and the modern application can be challengeable. The final one, managing the ecosystem complexity. So when we are delivering an automotive feature to the customer, it's not only between the cloud provider and the vehicle. In order to make this success, in the middle, we need to think about a good network provider, good ISP, it's mean internet service provider. To manage this whole ecosystem, it's very challengeable. Okay, now I think you get an idea about what are the challenges automotive industry is currently facing. Now we'll talk about how to mitigate these challenges, or how to reduce these challenges using key component of the resilient architectures. So here you can see some of the key components of the resilient architectures. If you need to build your automotive application with a high uptime or with high availability, you need to use some of these features. In here, I'm not going to talk about each and every boxes, because these things are we are discussing in the next few slides as well. But some of key components are really important if you are planning to deploy your application with a high availability. Especially you need to think about redundancy, high availability, load balancing, automated failover things. These are really important. Yes, we'll talk about how we can build our automotive application with high fault tolerance. What are the design strategies we can use? Yes, the first one is multi-region deployment. So what it's mean by the multi-region deployment? You can build your application in a different region, but in the same time you need to think about the cost as well, because to deploy your same application to a different geographical region, yes, it will increase the high availability of your application, but in the same time it will affect to your cost as well. So you need to manage between the scalabilities and the cost management. It will, this multi-region deployment not only increase the high availability, it's decrease the latency between the vehicle and the backend as well, because then all the users are not connecting to a central location. They are connecting to the nearest location that are available to them. So that's one strategy we can use, increase the uptime of our automotive application. The next one is auto scaling and the load balancing. Everyone aware about it. What's auto scaling and the load balancing? Auto scaling mean it will ensure depend on the demand of the request, your underlying infrastructure going up or going down, depend on the request, number of requests. So if we are seeing very high number of requests coming to our automotive application, your application automatically scale up or scale out. So that's the auto scaling. What the load balancing mean? Load balancer will ensure to divide all of this traffic evenly your underlying infrastructure without stressing a set of servers or the infrastructures. Then microservice architectures. So what's the microservice architecture mean? So without building your application as a full component, you can decouple features of your application. Why it is very important? Because then if something happened to your application, it will not impact to all the features of your application. It will impact to only few things, because you decouple your application to a small part without dependence with each other. Next, we'll talk about the continuous data backup. We talked this previously as well. So basically, we need, since automotive applications are keep changing, we need to take backup of these application more frequently. Also, we need to take backup to a different location as well, because if something happened to your primary location and if the backup also in the primary location, it's not necessary. So we need to send this backup to a different location. Also, we need to archive this backup, and we need to test retrieving this backup as well. The next one is a automated failover process. So you need an automated failover process. What's that mean? It means without a manual intervention, your traffic should be rerouted to another available region if something happened to your primary location. It should be automated. The next one is comprehensive monitoring and alerting system. So this one also very important when we are building a high fault tolerance application, because if you have a very good monitoring environment or monitoring system, easily you can identify what are the issues or what are the performance issues having in your infrastructure. Then depend on that finding, you can act accordingly. Next one is security measures. Nothing to talk about it, because it's a very important thing. We need to think about to protect the personal data in order to increase the high availability of our application. The final one is regular testing and simulation. So basically within your team you can do some chaos testing to your application. What it means by chaos testing, if I simplify, it's stress testing. We call it stress testing. Basically you can stress your application and get an idea about in which point your application will break, or how much load your application can tolerate. Depend on the output, you can decide whether if there is any improvements need for your application. So these are only few things that you can use for build a high fault tolerance automotive application in the cloud. Okay, some fun case studies. So now you can understand, after these case studies, you can correlate the theories that I previously explained with these practical scenarios. Yes, in 2019 September, Tesla faced a very broad network outage to their automotive application. During this network outage, some of their features got highly impacted, especially remote services and the OTA update. What's the remote service mean? We talked previously as well. Some people are using their mobile phone to control the vehicle. So that feature heavily impacted. And the other one is OTA update. What's the OTA update mean? OTA update mean over the air update. It means customers not required to physically visit to a service station or dealer to update their software versions or the hardware firmware version, because normally it's not happen. People are not getting off from their regular business hours, and they don't like to go to a dealer and update their software. So that's why most of the automotive companies providing this update over the air while driving the vehicle. So these two applications, OTA update and the remote services, heavily impacted during this outage. And the other thing, these two applications heavily rely on the cloud as well. Now we will see how Tesla used their resilient architectures to mitigate this issue. The first one, they use redundancy and failover. What's the redundancy and the failover? So Tesla deployed their application in multi-region or the multi-availability zone. So this outage happened for only, think about this incident happened for only one region, still their applications are available in a different location and still they are serving to the customers without any downtime, maybe with a small performance degradation, but still the application is working fine without any issue. And the failover, so we talked this previously as well, they had the automated failovers as well. From the monitoring tool, they identified, okay, in this region, there's a network outage going on, then automatically all the traffic is switching to some other availability zone. Still, then end customers can utilize all the features. Then the scalability, how scalability is important during such a scenario. According to my experience, I know normally after each and every outages, automotive companies can expect high number of requests coming from the users. Why it is? Because end users are aggressively trying to reconnect again with the backend, because once they identified, okay, my remote controlling systems are not working, they keep aggressively trying to reconnect with the backend. In that time, in most of the after the outages, we can expect high number of requests coming from the users. So scalability is the solution for that. Scalability is ensure, okay, I will handle all the incoming requests, increasing like scale up or scale out my underlying infrastructure. Then the monitoring and the rapid response. Tesla had a very good monitoring system to identify all of these issues and proactively work on these issues before customers identified this issue. The next one is customer communication. That also very important. So they inform this outage about customers as well using SMS or social media. Anyhow, they inform this outage to the customer. So what's the outcome and the lesson learned from this incident? So yes, Tesla had a very broad network outage for few of their services, but using resilience architectures strategies, they minimize the outage time. So then the customers also happy because during an outage they didn't get much impact the customers. So probably they will get very good satisfaction from the customer, and it will help to increase the Tesla brand reputation as well. Yes, the next case study, case study number 2. I name it as scalability in peak times. So in this case study, we are trying to understand how we can handle the increased load during the winter time. So this one also with my personal experience, because we know during the winter times, especially December, January, February, especially for this remote service, remote climate control, this service will get high number of requests from the customer, especially in the morning hours, because drivers are trying to preheat their vehicles before they use it. This is normally happen for all the this will face by all the automotive companies. So we'll talk about how we can proactively identify this high number of requests and how we can address this issue using cloud resilience architectures. We can use auto-scaling load balancing, as we discussed previously as well. So auto-scaling will ensure, depend on the high number of requests, it will scale up or scale out your underlying infrastructure and address all the incoming requests from the customers and reply all to them. The load balancer will ensure divide all the traffic between underlying infrastructure evenly without stressing a few components. apart from that, we can use predictive scaling as well. So that's why the monitoring is important. From your monitoring reports, you can identify, okay, each and every year during the winter time, especially morning hours, we are getting high number of requests to remote air conditioning system. So once you identify this pattern, you can provision high number of underlying infrastructures to address that traffic from the customers. The next one is the geographical distribution. So if you have multiple the same components of your application in the different geographical region, then all of these requests are not coming to the a single data center or the single application instance. As an example, think about your application is decided to your application is deployed in Stockholm and like France, Italy, likewise. Then all the Nordic countries requests are coming to Stockholm data center, because the France and the Italy request it's not required to come a long way to the Stockholm data center. So it will reduce the latency between vehicle and the data centers. Then monitoring alerts. So we talked this previously as well. We need a very good monitoring solution to identify all of these issues and proactively act on these things. The next one, elastic resource allocation. It's very similar to auto scaling. So I'm not going to talk much about it. So basically the outcome and the lesson learned or the conclusion from this case study also very similar. It's mean, yes, we identified we are receiving high number of requests specifically during the winter season to remote climate control services. So using cloud resilience key components, as example, auto scaling, load balancing, predictive scaling. Using these strategies, we build a resilient architecture to our application to handle this incoming traffic. Yes, now we'll talk about the security as well, because this is really important. Before talk each and everything, I will explain the correlation between how this security will be a main point when we are talking about the high availability and how its effect. So think about your application is running really good with the most of the key component of the resilient architectures. But if your application is a less security, you can expect a DDoS attack or data breach of your application. If it's happened, it's really impact to uptime of your application, because to fix these security breaches or the DDoS attack, it's not an easy thing, and it will take long time to patch your application. So that's why it's really important when we are talking about high availability of this application. So how we can mitigate or how we can use some of the key features from the security perspective. We can encrypt our data. So when we are encrypting, we need to encrypt this data in rest as well as while transiting. Also, we need to ensure zero unauthorized access to our application. Then we need to think about network security as well, like using firewalls or intrusion prevention system or intrusion detection system. Anyhow, we need to secure our network layer as well. Then you can do some regular security assessment like penetration testing, monthly vulnerability scanning, and also you can integrate a security tool to your daily the deployment lifecycle as well. Then the OTA security update. We talked this previously as well. We need to introduce the OTA security updates to the customers, and the compliance and the standard. So basically, when we are building our automotive application, we need to adhere to these regulatory bodies. So that's the importance of the security for the automotive application. Now I will talk about the monitoring and alerting part, the important and how we can build a very good monitoring system as well really quickly. So if we have a very good monitoring system, we can identify performance of our application. If there is any security breaches, we can identify it from the monitoring tool. Also, we can assurance about the reliability of our underlying application. Not only that, you can get idea about how the users are experienced about your application, and if need, you can generate a compliance report and you can share it with your customers. And we'll talk about how we can build effective monitoring system. Basically, you can use a threshold-based alert, like you can set up your monitors using warning alert in the 60% and the critical alert in the 75%. Like, it's depend on your application, but it's very required. And the anomaly detection. So in most of the monitoring tools are giving this feature, like anomaly detection. It's mean using machine learning algorithm or analyzing your past data. This anomaly detection will guess or will predict if something is going happen to your application. It's really good feature nowadays coming with the monitoring tool. So it's better to use these type of features. And the real-time notification monitoring and the dashboard, not only enough, you need to set up real-time notification as well, in that, because that only the required parties are aware about if something is going to happen. Yeah. Finally, we'll talk about how we can continuously improve this process. So we can learn from the incident. If we face any outage during the postmortems, we can discuss about how it goes wrong and where did we get wrong, as well as how we are going to prevent the same situation happen in the futures. So and you can share this knowledge with others as well. Then the other teams or others in your team can learn from your failures. The next one, continuously involve with the correct or the modern architectures. So try to build your application using microservices, and try to adapt to the CI/CD, basically DevOps cultures, and use infrastructure as a code. Also, every time use very good monitoring and the observability tool. The next one, every time adapt to the learning cultures, because if your team is very good and the very update with the latest technologies, this knowledge is helpful when they are troubleshooting any issues. So then finally, as we discuss, leverage on the cloud native features for the resilience. So basically, we can use auto scaling, load balancing, high availability, disaster recovery, as we discussed previously, and every time trying to utilize the managed services, because managed services are built with resilient key components. So that's all about my session. So before I wind up, I will quickly recap what we discussed today. First, we discussed about importance of the resilient architectures. Then we talk about some of the challenges that automotive industry is facing. After that, we talk some key components of the resilient architectures, and we discuss how we can build a high fault tolerance application in the cloud. Then we talk about some real-world scenarios and how resilient architecture help to mitigate these outages. After that, specifically, we talk about security and the monitoring as well. And finally, we talk how we can continuously improve this process. So yeah, that's all from my side about this session today. So again, thank you very much for everyone. And if you have any question or doubts, now we have plenty of time. We can talk about it. We can discuss about it. Okay.
I have a question.
As usual.
How easy for you is to implement disaster recovery and multi-region together?
Yeah, very good question, Claudio. it's very it's not an easy thing. That's why I mark it as a challenge when it's come to the multi-region deployment and the disaster recovery, because it's totally depend on nature of your application, because we need to think about whether we need a disaster recovery for this feature or not, whether we need to deploy this in a multiple region or not. If we talk about especially the security features like emergency braking system or automatic collision detection system, these features are really critical, right? So for these features, at least we need to deploy our application in a different region, like multiple region. If it's not possible, at least we have to utilize the availability zone within the same region, because up to now, I think we didn't heard about the entire region goes down from any of the cloud providers. Yes, it can be impact to only few availability zone, but not the fully region. So in that case, it's totally depend on the nature of your application. Depend on the nature of your application and the importance of your feature. We need to decide whether we need to build a disaster recovery, or it's only required multi-region or the multi-availability zone deployment.
I have a follow-up question.
Yeah.
How easy for you as a senior engineer is to justify the cost of the multi-region disaster recovery to a manager or stakeholder when you put numbers to it? How you justify that and say, like, look, the gains and stuff, like how you do that?
Yes, a really good question, and it's very hard to justify it to the management about the cost and this deployment, but I will answer your question like this. So as I explained earlier, we need to think about the nature of this application and the importance of this application. Think about, as an example, we are talking, we will get one feature like a remote air conditioning system. So now think we have deployed this remote air conditioning system in a one single availability zone. Now we are thinking about, according to your question, now we are thinking about, okay, do we need to deploy this application in a multi-region? So then we need to think about, if this application goes down, what's the impact for the customers, and within the SLA, service level agreement, if we not able to bring back this application online, what's the other circumstance happen from the customer level? How much penalty we need to give to our customers? Likewise, we need to think about the importance of your application, as well as the cost from our side. So if we think about, okay, during an outage, if our remote air condition system went off, and if it's totally unavailable for the customers, we need to think about how much it will cost from the customer side, how much penalty we need to give to them if we fail to bring it back within the SLA times. Then we need to compare it with the cost for the multi-availability deployment or the disaster recovery solution. So comparing these two costs, then we can decide, okay, are we going for the multi-availability zone, or are we sitting with the single availability zone? But it's okay for the feature like a remote air conditioning system, because if something happened to remote air conditioning system, it will nothing happen to the person who is driving the vehicle, right? It's like it's very hectic it's very hectic situation. Think about during the winter season, if you are trying to preheat your vehicle, and if it's not work, it's very hectic for the owner. But if we talk about the safety features like collision detection system, emergency braking system, or automatic emergency calling system, these are really important and really value from the customer. So in that aspect, we need to think about high availability of this application.
Thank you.
Thanks, Claudio. Tesla.
Yeah, they have overcome that problem from they have moved to the cloud to overcome that problem. So in your proposal is remember that when we go to our cloud providers like AWS or Azure, then you think we can overcome that that problem from that cloud providers, because I'm highlighting the latency and mobility. We are talking about the mobility vehicles. Then if you go to the cloud, sometimes the network and so many environmental
Yeah.
the latency can be varies. I guess it's 10 milliseconds.
Yeah.
Then how can we overcome that problem with
Yeah, good question, Chaturanga. So it's like this. If we specifically talking about the latency, these cloud providers are giving solution for these latencies as well. As an example, we can use, as I explained earlier, either we can use multi-region deployment or edge. Nowadays, most of the companies are using edge computing. What it's mean by edge computing mean the edge computers are located in very near to the data generated source. It's mean edge computers are available in most location, and those computers are getting the data from the most of the time these edge computers are used by the automotive companies, because then these edge computers are very near to the data generated source. It will quickly get the data and process without sending it to the centralized location. Not only that, you can use CDN, content delivery networks, to reduce the latency between vehicle and the backend. Yeah, your question is very valid, because we talk about the latency. It should be very less latency between vehicle and the backend, because we are talking about some security features. In order to work these security features, it should be with very less latency. But cloud providers are giving so much of resilient components to reduce the latencies.
One more question. This is a general question. Have you seen any AI part being involved in this resilient architecture in any of the service providers or any areas?
Yes, AI is now, I think that's the future. But I think still in the nowadays also they are using AI features to identify some of the issues. I will give some example. During my presentation, I talk about anomaly detection. These anomaly detections are purely based on the AI calculation, because it will analyze your previous data or the previous pattern or from other information from the other vehicles, and it will detect, basically using its AI powers, it will identify if something is going to happen to your application. So that's one thing. Other thing is especially for the autonomous driving. So this autonomous driving required very fast and very high powerful thinking patterns, right? I mean machine learning algorithm. To build this machine learning algorithm, or the to build this much of fast processing power, they are using AI calculations to do that.
And I have one example of that as well. Some companies are putting AI in analytics and all these things on the monitoring and also on the cost efficiency. So they will run all the data sets about the usage of the cloud and so on through the analytics and say like, yay, if you change this instance to that instance, you're gonna save money. If you change this to that, you're gonna save money as well.
Yeah.
So you have all of this integration with the AI already.
and also your gathering data import part is a vehicle-to-vehicle communication also. Is it considered from your proposal as well?
You mean?
Consider your proposal. The vehicle-to-vehicle communication, that's a communication.
Yeah.
Vehicle-to-vehicle, some data is processing. And,
Yeah.
that train data is uploaded to the cloud.
Yeah, as I know how it's happened in this automotive industry, not only V2V, it's like vehicle to vehicle, like vehicle to anything. That's the concept. So all of these data is processing in from the centralized unit in the cloud, and depend on this data, every time they are updating their algorithm, especially for the safety features. Think about automatic braking, automatic emergency braking system. We call AEB, automatic emergency braking. In order to work this automatic emergency brake, it's required so much of data. So these data will generate inside the vehicle. It means nowadays vehicles are coming with high number of sensors, cameras, radars, likewise. So using these sensors and cameras, it will generate the data, and there's a onboard computer inside the vehicle. We call it OBU. I'm not exactly sure. Sorry, telematic control unit, telematic control, TCU. So inside this TCU, this data is processing. So that onboard TCU is the one who getting decision. Okay, now I need to apply the emergency braking. But in order to think to TCU, all the algorithms are coming from your application that are hosted in the cloud. So as you mentioned that to generate this AI algorithm, these cloud hosting automotive application, they will get data from the vehicle to vehicle communication, from other vehicles, like some previous accidents. They will get all of these data and generating algorithms, and it will send to the vehicle over the updates. So that's how the entire process is working.
It should not be the real time.
It's real time. It's real time. But I need to explain this one. I mean, the emergency braking system in a vehicle, the decision is not get by the application that are hosted in the cloud, because it's very dangerous. These decisions are getting by the computers inside the vehicle. We call it TCU, telematic control unit. But to telematic control unit, the algorithms, the thinking pattern or the algorithms are given by these applications that are hosted in the cloud. So these algorithms are designing using the data that are getting from the vehicles or the past accidents. So what happens is, using this data, it's analyzed and it will give the correct or the most updated algorithm to the vehicles. So that's why we are using OTA update, over the air update, to provide this update to your hardware and the firmware.
Is the databases are also geographically distributed?
Yes.
Because in Europe region, mostly the trucks and everything, like those are coming from run away from the long run from like Finland to the so in that cases, this mirroring and those things are also you are proposing in the microservice architecture you mentioned. So like the databases are also geographically distributed.
Yeah, definitely. So if you get one single automotive application, not only the application service, all the databases are geographically distributed. But in these days, actually, most of the companies are now not using this like physical component like EC2 or RDS. They are most of the companies switch their infrastructure to serverless architectures. In the serverless architectures, actually, these resilient key features are inbuilt with these with the serverless architectures, because then it's not required to automatically set up threshold to auto scaling or downgrading your infrastructure. So it's everything happen from the serverless architectures. If we specifically talk about the databases, we have DynamoDB in the AWS. So you can set up these serverless databases within geographically region or within multi-availability zone as well. So the main advantage of the serverless is it's not required to maintain the underlying infrastructure by yourself. It's managed by the cloud providers. You need to think about only the deployment for these serverless architectures.
I'm sorry, what is your calling the unit from provider?
TCU, Telematic Control Unit.
Yeah. Another one, the cloud providers are giving to the
The edge computing.
edge computing.
Edge computing.
Or maybe CDN.
Yeah, it's a CDN, class content delivery network, and the edge computers.
All the features are treated equally, or the more critical it is, the more resources are allocated, or more attention, depending on the critical.
Yeah, exactly.
For instance, the brick system is more important than air conditioning.
Yeah, exactly. So that's why when we are designing this application, we need to think about the nature of this application, as we discussed earlier. Like remote climate control or the remote air condition system is, yes, it's critical, because critical mean it should be available around the clock, but it's not critical as safety features like emergency braking system, automatic emergency calling system. So when we are allocating resources and when we are designing with the high resilience architectures, we need to decide the nature of application, and we can distribute the resources depend on that findings. So I think you guys are aware about the what is automated emergency calling as well, right? So basically nowadays if a vehicle is if there is an accident in a vehicle, from the vehicle it will trigger automatic call to the emergency services and providing all the data like the impact to the vehicle and the location of the vehicle. It's very easy for the emergency service unit to quickly reach to the accident location.
Very nice. Thank you, Chamila. Round of applause then. We have here a small gift for you.
Thank you.
So much for sharing the knowledge.
Thank you. And again, thank you very much for everyone. Really appreciate all of your participate. Thank you.